Hello students, so today we are going to go through homogeneous differential equation. So let us start our class. So let us first go through the definition of it. So the definition is a function f of x comma y is said to be a homogeneous differential equation of degree n if f of lambda x comma lambda y equal to lambda power n f of x comma y. That means when you substitute lambda x in place of x and lambda y in place of y, then when you evaluate the function, or we can say the expression, then lambda power n should come out and you should be left with f of x comma y. Now in CBSE we have only linear homogeneous differential equation. That means degree should be 0. Okay. Now let us start with the algorithm. It has a very simple, straightforward algorithm. So let us go through that. First of all, you are supposed to write the given equation in this form. So f of x comma y should be on this side, one side, and dy by dx should be on one side. Next, what you will do is, depending on this function, after analyzing carefully, you will put y is equal to vx. In some cases, we will put x is equal to vy as well, which we will be going through in this coming session. So when you put y is equal to vx, then you will do the derivative. I am pretty sure all of you know UV rule. So applying UV rule, this is the derivative you will get and you will replace back. Now next what you will do is, after substituting y this and dy by dx this, you will not change anything else. Again I am repeating, y should be changed with vx and dy by dx should be changed with v plus x dv by dx. Then your equation should get converted to variable separable. If it is not getting converted, that means you have made some mistake during the process. So v and x, after doing that, you will separate everything on one side in terms of v, other side in terms of x, and thereby you will be doing integration on both the sides separately, and then you will be substituting back y by x in place of v, and you will be done with the solution. I hope the algorithm is clear to all. Let us proceed. Now let us see this equation. Now after looking at this equation, first what I told you, write dy by dx. Now this thing is your f of x comma y. After writing that, just for your satisfaction purpose, you can check. So f of lambda x comma lambda y, see, when you substitute lambda y in place of y, lambda x in place of x, and after taking common and everything, see, you are getting back the function. That means, as I said, lambda power 0. Lambda is completely getting cancelled after substituting lambda x in place of x and lambda y in place of y. That means this is a homogeneous equation and we can proceed with the algorithm that I explained just now. Now in this case, I will put y is equal to vx because I wrote dy by dx. After doing that, substitute back everything. Now, one mistake that I have seen students doing is, they will replace x also again as y by v, which is absolutely wrong. You should not substitute anything for x. Only in place of y, put vx, and in place of dy by dx, put this thing. That's all. X will not be touched at all. Okay, so you can see x as it is here, x square as it is. Only y and dy by dx is changed. Now after simplifying, you can see I am taking v to this side and then I am simplifying. Now bring everything in terms of v on one side and x on the other side. So as you can see, this is what we got. Now you can integrate because everything is in terms of v here, everything is in terms of x, and you have dx and you have dv. Now integral, you should be very good, otherwise differential equation will be very difficult for you. Now you can see this is a quadratic, so if you want, you can do completing the square. So we have two ways. If you want, you can do completing the square, or you can do partial equation. It means partial derivative. So what you can do is, partial fraction. So what you are supposed to do is, if you want partial fraction, I'll just say you just take v common, you will get 2 plus v. And then you can write this as a by v plus b by 2 plus v. And then I hope all of you know how to integrate further. If you don't know, please comment so that I can make a video on partial fraction as well. Here I am doing completing the fraction because this is much more convenient. Over there I have to find a and b. Here there is nothing as such. I am just doing completing the square. Completing the square. After doing that, I got v plus v whole square and x square. Now this is in the form of x square minus a square integral. And the integral of this is log x minus a by x plus a. X minus a by x plus a. One more very important thing you have to make sure is it should be in mod. In test, don't put bracket. It is supposed to be in mod. Okay. So it is half of log x. This is your x basically. This thing for linear minus a by x plus a. And over here you can see it's a direct integral. 1 by x is log mod x. Now you try to combine all log together. Now one more question that students ask me, ma'am, why should we take c? Some people will say I will take log c. Some people will say no ma'am, we will take just c. So what I am doing is I am just taking c because this is what most of the students tend to take. Because they don't get an idea whether to take log c. Sometimes you have to take e power c. They don't get an idea. So I'm just taking c, which is a normal integration constant. Now what I'm doing is I'm trying to find the constant value first. So this is the initial condition provided to me. At x is equal to 1, y equal to 1. So in place of x, put 1. In place of y, put 1. Before doing that, make sure you have converted back or replaced v by y by x. Okay. Now after solving this, I'm just substituting. I think calculation, if you have any doubt, you just write in the comment section. I will clarify. Moreover, I have written down all the steps. So you get this as your c. Now I'm writing c back here. Now you can see that 1 by 2 log x can be written as log mod x. Sorry, not mod x. It can be 1 by 2 log x can be written as log root x. Right? This half will go to the power. Same thing we are doing here. But moreover here what is happening is instead of doing that, what I am doing is I can see here I got half. I can see here also I got half. So I am just multiplying and dividing by 2 here so that I can just cancel. Again I am telling this is not just the only way to express your solution. There are many ways to express. Okay. So it can just cancel 2. Now this 2 I will take it as power x square. And this is log a plus log b. So that will be log. This is your a and this is your b. And here it is in log as usual. Now what I am doing here is see this minus 1 I am taking to the power. So 3 to the power minus 1 is 1 by 3. Now I can see there is log on both the sides. Now I have seen students telling that, and please in the test don't do like this. It is absolutely wrong. It does not make any sense. Just cancelling this log. We are not doing cancellation. We are taking inverse basically, or we can say that e to the power x is equal to a. So x equal to log a. That's what we are doing here. Okay. So what we got now, you can see as it is. So this thing is equal to 1 by 3. So I just cross multiply. Now one thing you have to make sure is, since it is in mod, the answer will come plus or minus. Right? As you remove this log by taking e on both the sides like e power, then what happens? This still remains in mod. So for removing the mod, what you're doing is you have to put plus and minus. Now if you miss this plus and minus, you will not get full marks. Okay. So this is your final answer. Now I know that most of the students don't write this plus and minus, but make sure that whenever you remove log, basically by taking e on both the sides, you are supposed to write plus or minus. Okay. So this is your final answer. Now, furthermore, now since they have given the initial condition, right? This initial condition should be satisfied by this. So I'm just applying the condition. Now when I'm applying, what is happening is this minus, we have two solutions, one with plus, one with minus. With minus, my initial condition is not getting satisfied. That means we have to eliminate minus sign and just keep the plus sign. So this is your overall solution for your answer. But in case it is getting satisfied, then you are supposed to put both plus and minus. Okay, so this is your final answer for the question. Going for the next question. Now, again I told you by looking at the question, don't worry in which form it is, linear or variable separable or homogeneous and others. But anyway, in CBSE we have only 3 forms: homogeneous, variable separable and linear. It's supposed to be in any of these. Now I'm just writing dy by dx in this form. Now what you do is you just check simply for verifying whether it is homogeneous. After verifying, I got the same function back. That means it is a homogeneous. Now I will take y equal to vx. Same process goes on, you can see. After that, you will be ending up with everything on one side in terms of v and other side on terms of x. So you can see that I keep on taking mod. After doing that, I just got this to this side. Okay, it was supposed to be log mod and I took to the other side. After taking to the other side, okay, now let me just make one small correction over here. It is supposed to be here minus sign. Okay, because here when we evaluated, you got log mod x. Now when I took this to the other side, it is supposed to come in the minus sign. Okay, please make that correction. Now after doing that, log a minus log b is supposed to be log a by b. That's what I have written. Okay, now you can see that I am taking e on both the sides. So when I take e on both the sides, this thing will be coming down and this will be e power c1. Okay, now what we are supposed to do is, now since I want to remove mod, what I should do is, as you can see, now one more thing what I am doing is, see, e power c1 is again a constant, so I am just writing that as c2. Okay, not big of a concern here. Now next what I am doing is, I am taking, as you can see, here it became mod x square, not a problem. Now again I am taking, because see, here to remove plus or minus, either you write in plus or minus or else you just square on both the sides. Once you square on both the sides, the mod plus and minus will be removed. You don't have to write plus and minus now. So this will be your final answer. This is not your final answer, because students, they don't write mod, they will just write like this and they will just write this is the final answer. That's not the final answer. You are supposed to remove the mod or keep it as it is at least. Don't write bracket. Okay. Now coming to a very interesting question. By looking at this question, I have seen most of the students will skip because they will be unable to analyze which form this question comes under. Now let me tell you that whenever you get something of this form which cannot be separated, the meaning cos y by x, whatever you do, you cannot separate y and x because it is an argument of cos. That means this will be together even in the expansion. If you do 1 minus x square by 2 factorial and all those things, if you do, it will still be there. It is a homogeneous. It will be homogeneous without checking, because in this you don't have to check also. If you check, you will still get, but there is no requirement here. This form is no chance is going to be linear or variable separable. What you will be doing is you will be going with homogeneous. So you will take, now let me again tell you, since it is y by x, I want just a normal like variable on the top. So I will take x equal to yv or y equal to vx. You can very clearly see that only if I take y is equal to vx, then only I will get this as v. So I don't want like a fraction form, I just need v. That's the reason I am taking y equal to vx. If it was in x by y, I would have taken x equal to vy. I hope it's making sense. Then after differentiating, substitute back y as this and dy by dx as this. Okay, so as of now I didn't substitute back because here dx and dy are separate, and after writing this in dy by dx form, as you can see, now I am substituting, and after substituting, this is all I got. I took v to the other side, then I just simplified. After, and students, make sure that I have seen students, they will multiply this v with this with this. They will forget that there is a minus sign which is supposed to be multiplied with this minus. Okay, so make sure you do the calculation perfectly, or else you will not get variable separable. Okay, now after doing this, you can see this is the form I got. Here everything is in terms of v, so I am just cross multiplying to make sure that I take this to dv, because dv and dx should be in the numerator. Now after doing this, there are many ways to solve, but with experience after doing integrals, you should have an idea that if you differentiate this, you will get this form if you just remove 2. Okay, so I'm just letting this as t, and when you differentiate, I got the numerator as well, just keeping 2 aside. So I just took 2 outside and you got minus 1 by t. Okay, now you just integrate as usual, simple, substitute back in terms of v, then again substitute back in terms of y by x. See, I'm keeping the mod as it is. Now you can see that this 2 log mod x, I'm taking this 2 here, so it became x square. Since it's x square, now I can remove mod, because x square is same as mod x square. Okay, so log a plus log b is log ab. That's what I wrote. Now after that, I'm taking e on both the sides. Now this is again some other variable which I am denoting by c. Okay, now again I said still in mod, didn't get removed. Now what you can do is, I am squaring on both the sides again, as you can see. Either you can leave your answer as it is in mod, or you can just square on both the sides. So this is your final answer. I hope this question is clear. Moving on to the next one. Again, something of this form where x and y cannot be separated. So as you can see, e power xy, e power xy, you don't have to worry, it is going to be homogeneous. Okay, so first I wrote here. Now, as I told you, it is now x by y, right? So what you will do here is, you can take x equal to dy by dx. In the previous case, it was y by x. So I took y equal to vx. Simple language, it's y by x. So I took y by x as v. Okay. Now in this question, it is x by y. So this is what I will take v. So x equal to y by v. Now you will differentiate with respect to x or y. You are going to differentiate with respect to y, not x here, because you need dx by dy. Okay. So first I wrote dx by dy, how we are supposed to write. Then I took x equal to yv. Differentiate both the sides with respect to y. So this is what you will get. Okay. Now after doing that, substitute back. Calculation, you can see it's pretty much clear. I've written all the steps, intermediate steps as well. Now it's variable separable, and you can differentiate keeping mod as it is. Right here, mod is there as well. Then after that, what we did is, this log a minus log b is log a by b. So a by b I just wrote, and after that I just kept it as it is. I didn't take again e power. It doesn't make the answer look very neat. This is not a very good way to express your answer, so I just left it as it is. Okay. Now coming to the next one. Next question, as you can see again, it is y by x. So as I told you, y by x means you will take y by x as v. Substitute back everything. Here the substitution is happening, and after that, this is what you got after cancellation and everything. Now it is variable separable. Integral of cos v is sin v, and one side you are supposed to put constant, and it's not necessary you have to put constant here. You can put here as well, but there is no requirement to put two constant here and here as well, because ultimately at the end you get only one constant, right? So I've seen students writing here also, and they will say, ma'am, why can't we write here? Yes, you can write, but ultimately you need to understand this will go to that side, and when you do cancellation and everything, you will end up with just a single constant. So why not just reduce your process? Okay. And after doing that, they have given some initial condition. At x is equal to 1, y is x by 4. Just substitute the condition, and from there you will get log 1 is 0, sin pi by 4 is 1 by root 2. So just substitute back. Now here you cannot do any simplification as such if you try to see. Right? It's not e power I cannot take. This is the good way of presentation. Now, one important thing that we need to understand here is, I told you one method to see whether it is homogeneous or not. Other method, after writing the equation in this form, if degree of each and every term in f of xy is same, then it is homogeneous. You don't even have to check this thing. Just by observing this thing, this given condition, you can conclude it's homogeneous. Let me explain you with an example. So as you can see, I took two different dy by dx, this and this. Term, by saying term, this is one term, this is one term, and this is one term, right? Now, how do you check the degree? Degree is sum of all the powers of the variable in that particular term. So here x power 1 and y power 3. So for this term the degree is 4. For this term the degree is 3. For this term it is 2 plus 1 3. You can see the degrees are different, so it is not homogeneous. This method will not work. The algorithm that we have gone through just now will not work. Next one, as you can see, is dy by dx equal to, here you can see, here the degree is 4, 3 plus 1 again 4. This is a homogeneous, and you can write y equal to vx and proceed. You will for sure get the answer. Okay, so just by writing dy by dx and doing this, you can get what is the degree. But coming to problems like this, in such problems you cannot find degree. Okay, because it is inside, y by x is inside, and that is the reason I told you, if you get such forms, you just proceed with homogeneous. I hope I made it clear to you. Best of luck for your coming exam, and I will be soon making another video on linear differential equation. All the best.